All right, so today we're in section 10.1, volumes of cylinders. Does volume mean the area outside of the figure or the inside? How much does it take to fill a figure? All right, you don't have to write all of this down. What do you notice about these two shapes? Oh, hold on, let me unfreeze it. What do you notice is different about these two shapes? One slanted, okay? The slanted figure, you need to know that that's called an oblique shape. It's not super important that you remember that, but they have it in here. So, all right, so it's called an oblique solid. All right, so you could write in your notes a slanted cylinder. The slanted cylinder is called an oblique solid. Okay, that would just be like a pretty easy, multiple choice type of question. I could give you that solid. I could say, what kind of solid is this? And you would say it's an oblique solid. All right, you calculate it the exact same way. Doesn't matter. Both of these figures, you calculate the volume the exact same way. All right, and how do you calculate the volume? There are two formulas that mean the exact same thing. V equals BH. Volume equals capital B. Capital B, guys, means the area of the base times the height. All right, well, here's why I don't love that formula. There is no dimension that you'll be given that is, well, that's my capital B. Because in order to find the area of the base, what did we just say the base was? What shape? What shape is the base? It's a circle. Well, how do you find the area of a circle? Anybody remember your formula? It's pi r squared. So that's why you're going to see us use this formula down here at the bottom. Because, guys, instead of having the capital B there, I replaced it with pi r squared h, which is the formula to find the area of a circle, and the circle is the base. All right, you see what I did there? Instead of a capital B that you can't plug in any one value for a capital B, now I'm breaking it down so I know where the values can plug in. All right, and all we're going to do today is we're going to look at this formula and plug in different values in different parts of the formula to solve. All right, you got it? So this formula down here at the bottom, that's the most important part of this whole slide. V equals pi r squared h. What does R stand for? Anybody know? Oh, wow, actually a couple people know. Caleb? The radius. So, does anybody remember what D would stand for in a circle? Radius and diameter. What's the difference between the radius and the diameter? I'm kind of getting ahead of myself here, but you guys are remembering, picking up on it. Faith?
Is the radius the inside of the circle?
It is, but the radius it's half, right? Diameter is all the way across, radius is half. And then H obviously would stand for height. All right, so here we have example 1. These are two separate scenarios. The first one, it gives me the information in words. The second one, it gives me the information in a figure or a drawing. You do not have to draw this drawing, okay? But they're two separate problems. And for both of them, I need to find the volume. All right, so right there, it says find the volume, solve for B. Or not B, V. Okay, so V equals pi r squared h. Meaning the volume equals, which is what I'm solving for, all of these figures multiplied together. Well, they have to have a numerical value that I can't multiply variables. Okay, so here's how it goes. V equals, anybody know the numerical value for pi? Just tell me. 3.14. So plug it in. 3.14 times r. What did r stand for again? R stood for the radius. Does anything in this problem tell me the value of the radius? Read the problem. Does it tell me the value of the radius anywhere in here? What is it, Robbie? It's 4. Okay, so I'm going to plug in 4 where r went in the formula. I have to square it, and now I multiply it by the height. Does that problem tell me what the height is? What's the height? 15 feet. Okay, calculators are allowed at this point, okay? But this part right here, what do I do here? 4 squared. Is that 8? Is 4 squared 8? 16. 4 times 4. Okay? So, what's 3.14 times 16 times 15? 3.14 times 16 times 15. Sam, what'd you get? 753.6. All right, 753.6. Oh, I forgot. We have to approximate all of our answers here. And the reason why is because of 3.14. 3.14 is a rounded value for pi, so we know that this answer will never, ever be exact. And whenever you find volume, you have to cube your unit. Okay, 753.6. And remember also in the directions it will tell you how to round your answer. Okay, so now I want you to look at this figure off to the right. Okay, so the only difference here is now you have a picture to look at. Do not draw this on your notes. Okay, just use your formula. Just like on your homework, you don't have to draw the figures either. Okay, use your formula, plug in these values, and find the volume. I'm going to walk around and check. All right, so V equals 3.14 times 3 squared times 6. Well, what's 3 squared? 9. All right, so 3.14 times 9 times 6. Oh, remember we have to approximate. 169.6 meters cubed. All right, did you get it? Did you get it right? Okay, so finding volume. Finding volume is just a matter of multiplying everything else together, and that gives us the volume. But what if I was given the volume? In these two problems, I know the volume, but I don't know the height. I need to solve for the height. All right, so again, you do not have to draw these figures. These figures are from your book, okay, both of them. On your homework tonight, you're going to start with your original formula. So go ahead and write it down. V equals, say it with me, pi r squared h. And now let's look at this information that we're given on the green figure. Where do you think 314 is going to be plugged in? 314. Where do you think you're going to plug that in? In for, what was it, Kendall? Plug it in for V, right? It says the volume is 314. So plug it in for volume. 314. You see that? That's your total. That's your volume. Do we know the value for pi, or at least the rounded value? 3.14. Do we know the radius? Look at the figure.
No. Yeah. Oh.
What number would I plug in for the radius?
5.
Is it 10?
No.
No, 10 is the what? Diameter. 10 is the entire distance across. So if I need to know the radius, which is half the distance across, what can I do to 10? Divide it by 2. half it. What's 10 divided by 2? 5 squared times h, which I don't know. Okay? So now I can multiply the numbers together. What's 3.14 times 25? What's 3.14 times 25? Yes, that's correct. 78.5. H. All right. Nolan, how do you think you're going to solve for H at this point? Bailey, can you help him out? Divide both sides by 78.5. Okay, and then H, again, remember guys, it's approximated because that 3.14 is a rounded value. When I approximate it, H is approximately 4 inches. 4 inches. All right, I want you to do the yellow one. Okay, the same way. All right, go ahead and do the yellow one. Guys, V equals, well, let's just plug it in for V. What was the value for volume? 176 equals 3.14 times, what is the radius? 4 squared times the height. So 3.14 times 16 is what? 50.24 H. Divide both sides by 50.24. And H is approximately 3.5. 3.5 centimeters. All right. Who got that right? 3.5. Okay. Rounding to the 10th. Rounding to the 10th. All right, guys. Example 3. Finding radius. Okay, finding radius. So by this point in the lesson, you should be kind of getting the hang of doing those substitutions. Okay, so we do the substitutions into the formula pi r squared h. All right, just as a reminder, that's going to be your original problem for all 4 homework problems tonight. Okay, V equals pi r squared h. Do I know volume?
Yes.
What is it?
226.
226. Do I know a value for pi?
Yes.
What is it? 3.14. Do I know the radius? No. It's r squared. Do I know the height? Yes. It's 8. So now I have something different happening here. I have the variable in the middle of this expression. All right? But commutative property, guys, it's a beautiful thing. I can actually multiply these. I can rearrange them because it's all multiplication. So I can do 3.14 times 8. I can go ahead and do that. What is 3.14 times 8? I heard it. 25.12 r squared. Okay? Now I need to solve for r. I do have an exponent connected to it, but that's not a huge deal because we've learned how to solve equations with exponents. All right? It's just been a couple weeks. But what do I need to do first? Before I worry about that exponent, what would I do first? What is step 1 to getting r by itself? Can anybody raise your hand and tell me? What's step 1 to getting r by itself? Kayla?
Divide by 25.1.
Yes. It's multiplication, so you divide both sides by 25.12. 25.12. And what is 226 divided by 25.12? Yes, you are going to round. Well, let's keep it on that side. 9 is approximately r squared. It's like 8.99 something. Okay, it's so close to 9. And we know that 9 is a what? What is 9? 9 is a perfect square. So that's why we're going to go ahead and round it, because we know to get the exponent to cancel, I have to do the inverse of a square. And what is, Chloe, the inverse of a square? The square root. All right, so I take the square root of both sides. Can my answer be positive and negative? In this scenario, can it be negative? No, why not? No, doesn't have anything to do with that. What am I trying to find? What am I trying to find? I heard it. The measurement. I can never have a negative measurement. That's why. Okay, so R is approximately 3 feet. All right, so now I have a challenge question for you guys. Look at this cylinder. Which one of these statements is different? Technically, there's 2 answers. Which one is different? Which statement is different? There's one statement that's definitely different from the other 3 statements. Kendall, what do you think? Yes. Is that what you were thinking? Why? Why is that statement different from the other 3? Yes, the other 3 talk about filling or capacity, but that one talks about covering, which we know is surface area, not volume. Okay? All right, guys, so that's going to wrap up section 10.1. That's all you need to know.